Hi guys. This lesson is a bit more of an introduction into human evolution, specifically looking at primates and the evidence that shows that we came from primates. So like I said, in this lesson we're going to start off with a bit of a geological time analogy. So a way, just like last week when we did the toilet paper timeline, showing that really our little piece of evolution is quite small compared to what has come before us. And then the next part is going to be on evolution, particularly of primates, their classification, and particularly the characteristics of primates. So let's have a look at this one. So this is just a way of looking at the vastness of geological time, everything that's come before us, and then our tiny little piece that fits in there. So if we look at it as if it was a calendar year, January the 1st would be when the Earth was formed. March the 1st would have been when we had the first lot of life, which was bacteria, so single-celled organisms. It wouldn't have been until August 15th that we got the first multicellular organisms. November 18th would have been the first vertebrates, so the first organisms with a backbone. December the 1st of that, if we're looking at it as a whole year, so not until the very last month, would we have gotten our first land animals. A few days later would have been our first insects, and then our first reptiles. December 13th would have been our earliest dinosaurs, with December 14th being when our first mammals appeared. A few days later, our first birds. And it wouldn't have been until December 21st that we got our first flowering plants, which really set off a lot of evolution with all the flowering plants, gave a new lot of nutrition as well. December 26th would have been when our dinosaurs became extinct, and that was when we really saw our first primates. The dinosaurs would have kind of ruled for quite a while, and primates had to stay quite small. Like we're talking, if you know what a pygmy marmoset is, it only gets up to about 200 to 400 grams. The primates, when dinosaurs were around, would have had to have been very, very small. So once dinosaurs became extinct, that's when we got lots and lots more primates. December 29th would have seen our first monkeys, with December 30th being when we'd see our first lot of apes. At 12 o'clock on December 31st would have been when chimpanzees and humans would have diverged. Okay, so we don't know what that organism was that we shared a lineage with, but chimpanzees went one way, humans went the other way, so we diverged, opposite obviously of converging. 1140 on December the 31st would have been the first modern humans. 1154, so within the last 6 minutes of this year, if we're talking about geological time as one single year, humans would have moved out of Africa to Europe. At 1157, the Ice Age would have ended. At 1159 was when we first domesticated animals. 11:59 and 46 seconds, we're going down to the last few seconds now, would have been when the Christian era began. And 11:59 minutes and 59 seconds is what is considered our lifetime. Okay, so really the amount of time that we've been on Earth as humans is very small compared to everything that has had to come before, just so that the conditions were perfect in a way that we could have diverged from chimpanzees, and then we've had that last little bit of time as humans. So the evolution of primates. So humans, apes, chimps, and monkeys are all examples of primates. Primates probably evolved from small arboreal insect-eating mammals during the major adaptive radiation of mammalian species after the dinosaurs became extinct around 65 million years ago. So there's a few words in there for us to talk about. So arboreal. Arboreal means that we would have been living in trees. having dinosaurs, they were the ones that ruled the earth at that time. So any primates that would have been around would have been very small and living in trees to get away from these huge big dinosaurs. We would have been insect eating. So small insects, easy to catch. We were small as well, so we probably didn't need a huge amount of nutrition. We didn't necessarily need meat at that stage. Insects were enough to keep us going. So then I've said during the major adaptive radiation. So what that means is after the dinosaurs became extinct, suddenly there was all this new area that could be explored, and it meant that very quickly different organisms were evolving to take up those places that were originally taken up by dinosaurs. So there was now different places that could be lived in, new habitats, food that had become available. So there was this, all of these different organisms were evolving all at that time, and that's known as adaptive radiation, when you get a sudden increase in the amount of evolution happening to fit in with whatever new habitat has come about. Okay, so many different human-like species existed over 4 to 8 million years since our lineage split from apes. Collectively, we call these species hominids. So hominids covers everything that, apes, chimpanzees, but also the things that we've only found fossils of. So some of our ancestors that we haven't quite got up to, but would be things like Homo erectus, Homo neanderthals, all of that kind of thing. Some of these species would have lived at the same time, and not all of them are direct ancestors of modern humans, but in some way they played a role in us evolving to become Homo sapiens. So here's a little evolutionary tree for us. So this is the 60 million years ago when, or 65 million years ago when dinosaurs became extinct. And this is all this adaptive radiation we see, all of these new organisms evolving. We're down here. Okay, and if you look at this graph, it's showing about 5 million years ago since whatever this ancestor here of ours was, then split into two groups, being the chimpanzees and us. Obviously, there's a whole lot of other species in here, but eventually we got to us as humans. So these trees also show how closely related we are. So we are closely related to chimpanzees, especially bonobo chimpanzees, which we're going to look at a little bit soon. We are less related to gorillas, and then as you go up, it becomes less and less related. So orangutans, gibbons, old world monkeys, new world monkeys. So the further along we are, since we diverged from that species, the less related we are to them. So our DNA, I think, is somewhere around 98% similar to chimpanzees. So Alan Wilson, you may have heard of the Alan Wilson Centre. He was a New Zealander, and he was very much involved in working out when we split from our ape-like ancestors. So up until the 1960s, it was thought that the earliest humans split from their ape ancestors 20 million years ago. So don't forget, 1960s, not so much technology that can be used to work out how similar DNA is. It would have been based on fossils and the old ways that they would have had of working out the age of some of those fossils. So Wilson's work showed humans and apes diverged only 5 to 6 million years ago, and we still actually use that date of about 5 to 6 million years ago. So Alan Wilson was born in New Zealand. He studied at the Otago University before leaving to study in California, and he remained there until his death in 1991. Wilson was one of the first to use genetics to study how species are related to one another. And now, of course, genetics is one of the main ways that are used to work out a lot of this lineage. Some of that DNA can be collected from fossils, and there's another New Zealander we'll talk about later on in the unit who used DNA that was found in the toe bone, I think, of a Neanderthal or a Denisovian. I'll have to check that one. So, classification of primates. And if you remember, the easiest way to remember this here is Kiwis play cricket on flat green surfaces. Okay, so if you have a look going down from kingdom, so kingdom being the biggest classification order, right down to species, which is the most specific, we start splitting about here. Okay, so really we are very related to chimpanzees and gorillas. As I showed you before, we are more related to chimpanzees and a little bit less related to our gorillas, to the gorillas there. Okay, so the main difference is when we get past family, so we're in the same family, but the genus is different. Okay. Just in case you've forgotten what a gorilla and a chimpanzee looks like, gorillas here, they tend to rely mainly on knuckle walking, so quadrupedal, using their arms and their legs to walk around. Chimpanzees, on the other hand, they tend to spend a little bit more time walking on two legs or being bipedal. Difference in there are some features of their faces that are quite similar. Okay, they each have this kind of raised bit here, which we call a brow ridge. They've got the eyes on the front of their face. So if you think about something like a rabbit, their eyes are on the side of their faces because they are usually what is eaten by another predator, whereas these guys here are really the predators. So classification of primates. So the term hominins is used to refer to living and fossil species belonging to the human lineage. And hominins is the word that I'm probably going to use the most in this unit when we're talking about who I mean when I'm talking about our lineage, especially so human lineage. So chimpanzees are our closest relatives, looking at about 98.6% of our genetic info being the same. That number changes every now and then, but it's saying about 98% is safe. So characteristics of the anatomy shared by primates. So looking at any of our primates, we all have pentadactyl limbs. Okay, pentadactyl meaning that there are 5 digits to our limbs, our hands and our toes. Chimpanzees have a slightly different hand structure. Their thumb is further down, so they can't do the same grasping as we can. And we also have different grasping to what they can. Theirs is still designed to be swinging on trees, whereas our hands aren't really designed for that anymore. Plantigrade feet mean that they are flatter, but we do have an arch to them. And that is so that we can walk long distances comfortably. Number 2, dexterous hands and opposable thumbs. So dexterous meaning we can use them for grasping, and we have 2 different types of grasping. We have where we can hold something like that quite strongly, and so precision grip and power grip. Okay. Chimpanzees can't quite do the precision grip the same as we can because of where their thumb is on their hands. Opposable thumbs, again, can be moved. Chimpanzees also have opposable big toes. We don't have that. And again, that's something we would have lost from not living in trees, not being arboreal. Number 3, our fingers and toes have nails, not claws. And that is all to do with increased sensitivity. We also have the ridges that make up our fingerprints, and that increases how sensitive our digits are. Number 4, our eyes are on the front of our face, and that gives us binocular vision, so we can see in 3D. We also have quite a range of vision as well. Number 5, we have colour vision. The colour vision that chimpanzees might have might be slightly different to ours. but they still have colour vision. Number 6, we usually only have one offspring at a time. Obviously, yes, you can have twins, and people can have more than that at one time, but ideally you only have one offspring at a time. And that is to do with how much you can carry, and also that our species only have 2 nipples. So we can only feed up to 2 at a time, ideally. Number 7, a large complex brain. So chimpanzees, for their body size, do have quite a large brain. Their brain isn't maybe as complex as ours. Ours has many folds and many specialized areas, though for their size, it is still very complex. In primates altogether, as a group, the visual areas of the brain are really large, though because of our visual area being larger, it has meant that other areas have gotten smaller, in particular our olfactory, or this region that is responsible for smell has gotten smaller. So you kind of got to go, one thing gets bigger, the other's got to get a little bit smaller. There's only so much that can fit up in there. Some more characteristics. Gestation, so how long you are pregnant for, is longer than in most mammals. I'm not quite sure on the gestation for chimpanzees, but obviously humans is 9 months. And again, typically one young per pregnancy. The gestation being longer is also to do with the fact of us being bipedal, so walking on 2 legs. Our pelvis has had to change shape quite a bit so that the young that does come out is very dependent on the parents. So that's the second point there. So infancy is prolonged with long periods of infant dependency. Recently, when I went to the Hamilton Zoo and got to see some of the chimpanzees there, they have about an 18-month-old chimpanzee there. She will remain kind of holding on to her mother and not going too far away from her mother for at least another 6 months, if not longer. Their infancy doesn't really finish until about 5 years old. At 5 years old, they are considered one of the troop and will be, dealt to just the same as if they did something wrong as the rest of the troop. So once they are 5 years old, they are considered an adult in the chimpanzee troop. But she will stay with her mum until she's about 2 years old, and then from 2 to 5, she'll start venturing out by herself a little bit more. But because of the shape of our pelvises, baby needs to come out being quite a bit smaller. So their brain isn't developed yet. Their brain is the biggest thing of their body. Their head is the biggest thing. It takes a while for all the connections to connect up, really, until they can actually start walking and talking and fending for themselves. Primates are cave strategists. And I hope from our last unit we remember that cave strategist means that they care for their young for quite a long time. So there's a large amount of parental investment. Like I said, that young chimpanzee will kind of be hanging off mum until about 2 years old, being very close to mum until about 5 years old. Obviously in humans, we're talking 18 years if we're lucky, sometimes well into our 20s. So yes, there is a very large parental investment, but when you're only having one young at a time, the nurturing increases the survival rate. If you're only having one baby and it takes a long time for you to get that one baby, you're going to spend a lot of time looking after it to ensure it survives. Next point there is that there is a reduced snout and a flattened face. Chimpanzees, especially gorillas, still have quite a long snout. One of the characteristics of being human is that we don't have much of a snout and our face is really quite flat. And that's one of the characteristics they use when they find a new fossil. They kind of look at how flat the face is. We also have a chin. We have really quite a pointy chin compared to any other type of primate. And our last point there, primates have a generalized dental pattern, which helps them adopt a flexible omnivorous diet. So chimpanzees, yes, still have very big canines. That's more in males, and that is used more for display. So when 2 males might be fighting over who gets to mate with what female, they will kind of snarl at each other, show off those canines. They might fight, they can use them, and they definitely cause puncture wounds and that kind of thing. In the chimpanzees. But primates generally have just a normal set of teeth so that they can eat a mixture of meat, but also any other plant materials. Obviously, we cook our food, so that helps with being able to eat almost anything. The last slide here is a link for you to go and have a look at. It's about Kanzi, the bonobo. So as I said before, we're about 98.6% similar in our DNA to chimpanzees. That is especially true for bonobos, a certain type of chimpanzees. So there's a really good talk there about Kanzi. It's almost quite scary about how much he can do. He's considered to be somewhere kind of maybe about the language skills of about a 5-year-old. He can't necessarily talk, but he can understand. And the things that he does in the videos and anything you can find on YouTube, and I've saved a few to our playlist. It's really, to me, it's kind of scary seeing this animal doing the stuff that seems quite human. So have a look at that. It's really interesting all at the same time. So that's everything. Don't forget to have a look at the week 2 folder for any other work to be done. There's some SciPad pages. Otherwise, I think that's everything for this week. Thank you.